So graphing transformations of quadratics. So this is what's called our parent function. It's the beginning quadratic. It has the basic shape of this. It goes to the point 0, 0, and it looks like this on a graph. Well, if we were to add or subtract some number on the outside, it shifts whether it's up or down. So since this is a -5, we take our basic function and we shift it down 5. So rather than starting at 0, 0, 1, 2, 3, 4, 5, it's going to start 5 down and be the exact same graph, just shifted down. So these two are the same function, just starts at 0, 0 for the basic, gets shifted down 5, and every point thereafter to be the same graph but moved down. Well, h of x has that -5, so it's also shifted down. But this 2 inside, so the inside shifts tell us whether to go left or right. Whereas this one told us to go up or down. Well, this happens the opposite of what you think. And this happens the same of what you think. So since this is a -5, we went down 5. But since this is a +2, instead of intuitively you think it goes to the right, but it goes the opposite. It goes to the left 2. So, if we take our start function, it starts at 0, 0, and we go to the left 2 and down 5, our function starts over here at -2, 5, and then goes up. So it's the same function, it just gets shifted over to the left and down from this function. So, let's list what these ones would be shifted like compared to x squared. So if we had f of x equals negative x plus 3 squared plus 1, we would take the x squared graphed and we would shift up by 1 because of this. We would shift left by 3 because of this. And what this does is it reflects it over the x-axis. So in other words, instead of opening up like this graph, it's going to open down. Okay? Say we have f of x equals 2x minus 1 squared minus 4. Well, shifted, so we start with our x squared, shifted down 4, because of here, shifted right 1, because it's the opposite of -1. This 2 stretches it by 2. So in other words, if it was a graph that was normally like this, it would become even steeper. So it would go up faster by double. Well, this is when they're already in this form. So what happens when we're in a form like this? This, we can't automatically tell the shifts. This is not in the correct form. This is called vertex form. This needs to be in vertex form before we can tell that. So to put it in vertex form, remember we complete the square. So, since we have videos on completing the square before now, I'm going to do this a little bit quick, just so you can see the transformation. So we add and subtract the same number. Well, that number is -6 divided by 2 squared. So that's, in other words, -6 divided by 2 is -3, and squaring that is 9. So we're going to add and subtract 9 to this function. This now factors to be x minus 3 squared. The -3 comes from here, the b divided by 2. These combine to make -5. So now that this f of x is in vertex form, we'd say comparing it to the x squared function, it gets shifted down 5 for this guy and right 3 for this guy. Do one more like that really quick. F of x equals 2x squared minus 8x plus 5. So to complete the square, the first thing we have to do is factor out the 2, and we have to pull it out of both things we have on the inside. So we pull it out of the x squared, we pull it out of the 8. then we don't pull it out of the 5 because the 5 is not in this set of parentheses. But because we're going to add some number here that's going to be multiplied by 2, we have to subtract the same number that's multiplied by 2. Completing the square here, negative 4 divided by 2 squared is negative 2 squared, which is 4. So the number we put in our blanks is 4. This now factors, the 2 stays out front. It becomes x minus 2 squared. Out here, well, this is the same thing as minus 8, so 5 minus 8 is negative 3. So now that this is in vertex form, if we compare it, we have an x squared to begin with. We shift it down 3, right 2, and we stretch it by 2, by a factor of 2. Factor of. So in other words, every y value, factor of 2, sorry guys, every y value gets doubled.